Here's number 25 from section 3.2. We're asked to find lines that are tangent and normal to the curve at the given point. In number 25, our curve is y equals 2 times the sine of pi x minus y, and our point is 1, 0. So of the two pieces of information we need to write the equation of any line, we already have one. That's the point. And that point in this case is 1, 0. The other thing we need is the slope of the line. And we're going to get that from the derivative. So let's start out by finding the derivative of y equals 2 sine of pi x minus y. And we're going to have to do that implicitly. So we want to take d dx of both sides of this equation. So the derivative with respect to x of y equals the derivative with respect to x of 2 sine of pi x minus y. And then we move on. The derivative with respect to x of y is just symbolic. It's dy dx. On the right, we're going to work this like a chain rule. So the derivative of 2 sine is 2 cosine. Keep the inside function of pi x minus y. And then multiply by the derivative of pi x minus y, which is pi, just by the constant multiple rule, minus the derivative of y is, we already said, dy dx. Now we run into a bit of an issue in the second step of implicit differentiation, where we normally gather together the dy dx terms on the same side of the equation and push everything else to the other side. In this case, the dy dx that is on the right side of the equation is, for lack of a better word, trapped inside parentheses, and it's not able to be moved freely from left to right on this equation. So what we're going to have to do is treat the 2 cosine of pi x minus y like it's the term getting distributed inside of the parentheses pi minus dy dx, like any sort of distributive property problem. Once we do that, we'll be able to move the dy dx terms around. So let's get to it. Dy dx on the left is now equal to, we've got the 2 cosine of pi x minus y multiplied by pi. So I'm going to call that 2 pi cosine of pi x minus y. Next, we've got the 2 cosine of pi x minus y multiplied by the negative dy dx. So I'm going to call that minus 2 cosine of pi x minus y times the dy dx term. Now that dy dx term is free to be moved about the equation. So we're going to move it to the right and gather it together with the other dy dx term. And on the left side of the equation, it's going to be a positive term. It'll change sign. So that's plus 2 cosine of pi x minus y dy dx. And now that's equal to that remaining 2 pi cosine of pi x minus y term. Okay, next, we'll factor out the dy dx. dy dx comes out of the 2 terms on the left. That leaves 1 plus 2 cosine of pi x minus y. On the right, we still have 2 pi cosine of pi x minus y. And then finally, solve for dy dx by dividing both sides by 1 plus 2 times the cosine of pi x minus y. Do that again over here, divided by 1 plus 2 cosine of pi x minus y, and we have our derivative, dy dx equals 2 pi times the cosine of pi x minus y, and that's over 1 plus 2 cosine of pi x minus y. All right, next up, we want to use this derivative to find the slope of the tangent line. So we're going to plug in the point 1, 0. So here's what that looks like. 2 times pi times the cosine of. In place of x goes a 1. In place of y goes a 0. So this just turns out to be 2 cosine of pi. In the denominator, that's 1 plus 2 cosine of. Again, replace the x with 1 and the y with 0. So that leaves us with cosine of pi once more. Well, the cosine of pi is negative 1. So now we have 2 pi times negative 1 over 1 plus 2 times negative 1. That leaves us with negative 2 pi in the numerator, and in the denominator, negative 1. So finally, we have a simplified slope of 2 pi. So let's write our answer. For part A, the tangent line, we have y equals the slope, 2 pi, times x minus the x value of the point of tangency 1, and then plus the y value of the point of tangency, which is 0. So we'll just kind of leave that there as an answer. For part B, the normal line, we want to write essentially the same line again, except we take the opposite reciprocal of the slope. So rather than 2 pi, it's negative 1 over 2 pi, and then times the x minus 1 once more. Let's box those in. That's a final answer for number 25.